Hydrogen bonding is very strong dipole-dipole attraction, around 10% of the covalent bond. So hydrogen bonding is quite strong. It just occurs between hydrogen and FON, FON, OO and F, oxygen, nitrogen, and fluorine. Okay, like hydrogen and fluorine, hydrogen and oxygen, and hydrogen and they're very polar. Okay, so hydrogen bonding. So on this area, hydrogen between the oxygen. Okay. And then hydrogen between the nitrogen. Alright, so we can say one lah. Yang ni pun sama. Yang ni pun sama sebenarnya. Ini pun sama, but we just choose one. Hydrogen with nitrogen. Okay, and then also there is actually here as well. Hydrogen and oxygen. Hydrogen and fluorine. Okay, hydrogen and fluorine. Then hydrogen and nitrogen. And then oxygen and oxygen. Alright. In water, that is a common thing that we see. Hydrogen bonding are very strong. It's responsible for high boiling point of water. So it's responsible of water, expansion of water as it freeze. Okay, so it's expand bila dia boil, it's freeze. It's expand bila dia freeze, is break bila dia boil dia pecah kan. Okay, so hydrogen bonding dotted line between the water molecule in ice form tetrahedral configuration. For example, this one. Hydrogen bonding in water, you must know this is between H2O. This O electronegative, hydrogen is electropositive, this is electropositive. So it has around 1.97 and strong. It's very thick, very strong as well. So between this H and O, it has around 0.97. So this is much more stronger. So that's why we choose this one compared to this one. Okay. So ion dipole attraction between ion and charge end of the polar. So the example of ion have full charge, increasing the attraction. This is negative end of water surrounded cation. So positive, okay, surrounded by negative, surrounded by negative, surrounded by negative, surrounded by negative. So they can attract. Okay, this is the ion dipole. Okay, or negative, surrounded by positive, 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 positive. So this is also, alright, create the ion dipole. So for example, AlCl3 6H2O. Alright, so this is attraction between ion and polar molecule. So positive of ion 3 plus is partially negative, attract the charge on oxygen. So attract this one, attract this one, attract this one, attract this one, attract this one. This is become ion dipole attraction. It's whole water molecule to metal ion in the hydrate. Okay, so water molecule are found in vertical octahedron. Ni nampak ni 6 octahedron ni. 1, 2, 3, 4, 5, 6. That's why when water freeze, we have the snowflake. Okay, this is the structure of snowflakes when water freeze around it. Ion-induced dipole attraction. Okay, attraction between ion and dipole is induced on neighboring molecules. It depends on ion charge and polarity of the ion neighbor. So attraction can be quite strong as ion charge is constant, unlike instantaneous dipole line. So this is how we can say ion dipole is the strongest, followed by hydrogen bonding, followed by dipole-dipole. London forces is the most weakest. Okay, larger, longer, therefore heavier the molecules, one have stronger intermolecular forces. If you have smaller, more impact, lighter molecule, you have relatively weaker intermolecular force. So these are intermolecular forces and temperature. As we increase the temperature, okay, intermolecular forces will be decreased. Okay, right. So that's why when we heat water, for example, we increase the temperature up to 100, intermolecular force will be break among each them. So it's increase the kinetic energy. Yes, of course, we're going to move faster to overcome the attraction force. But if we allow it to expand, increasing temperature, since distance between the gas and particle will be decreased the attractive. That's why arise between molecule of hydrogen bonded to small, highly electronegative and lone pair. So yes, so this is hydrogen bonding acceptor, hydrogen bonding acceptor. Okay, hydrogen bond donor. This is hydrogen bond donor. This is the donor. This is the acceptor. Who going to accept? So this is what happened. Hydrogen bond is stronger more than van der Waals forces. Because of this is you don't need to know it's exactly, yeah. Alright, so H2O has higher boiling point than HF because of HF is more electronegative. So you can just read H2O is able to form 2 hydrogen bonding, HF only form 1 hydrogen bonding. Type of intermolecular forces exist between each of the molecule. HBr, dipole, polar, dipole forces, dipole forces. Because we have the dispersion force between HBr, CH4, non-polar, so it has dispersion force. SO2, it has polar molecule, so it's dipole force. Okay,